Hello everyone, welcome to Sangam tutorials, SP Gubbi online classes for Ncert 10th standard and Cbse 10th standard mathematics and science classes. So in the last session of mathematics we had done with theorem 2 that was based on Sas Similarity Criterion. So if two triangles are equiangular then they are similar, or if two triangles are equiangular then their corresponding sides are proportional. So both the statements we proved it logically by using some lemmas. So in today's session we will be going with another criteria to prove that the two triangles are similar, so and that criteria is Sas criterion for similarity of triangles. So very simple, the theorem is very simple, but before entering into the Sas criteria of similarity we have to first understand certain basics, that is the previous knowledge required before proving the theorem. So we'll go with lemma 1. So according to lemma 1, if two triangles are equiangular, that is I have a triangle, I have another triangle here. So in these two triangles we will call it as ABC and take it as PQR. So this angle is equal to this angle is equal to this angle, and this angle is equal to this angle. So these two triangles are equiangular. So if two triangles are equiangular, compulsory they will be similar. They will be similar because their corresponding sides will be proportional. So in triangle ABC and triangle PQR, angle A is equal to angle P, angle B is equal to angle Q, angle C is equal to angle R. That is the triangles, both the triangles are equiangular because their corresponding angles are equal. So equiangular. So if two triangles are equiangular then they are similar because their corresponding sides will be proportional. That is AB by PQ will be equal to AC by PR, which is equal to BC by QR. So therefore triangle ABC is similar to triangle PQR. So this is, if two triangles are equiangular then they are similar, or if two triangles are equiangular then their corresponding sides are proportional. So this is the previous knowledge, that is lemma 1 required for proving this theorem. Right. So let us get into lemma 2. Right. For example, we have triangle ABC. Consider triangle ABC. We will take another triangle. Take it as triangle PQR. Now, these two triangles are congruent. Triangle ABC and triangle PQR are both congruent. That is, triangle ABC is congruent to triangle PQR. So you have to remember this concept here. If two triangles are congruent, no doubt they will also be similar. So if two congruent triangles, right, are always similar. Two congruent triangles are always similar. So if triangle ABC is congruent to triangle PQR, therefore triangle ABC is similar to triangle PQR. Reverse is not true. Reverse may be true or may not be true, but this is 100% true. That is, triangle ABC is congruent to triangle PQR. 100% triangle ABC is similar to triangle PQR. So congruent triangles are always similar, but similar triangles are always congruent. May or may not be true. May be true or may not be true. So one thing is very clear: if two triangles are congruent, then they are similar. So this is lemma 2. So let us get into lemma 3. Very important. That is converse of BPT. Converse of BPT. Right. So this is, let us take a triangle. This is triangle ABC. A line divides, the line PQ divides the two sides of the triangle, that is AB and AC, in the same ratio. That is, divides, the line PQ divides the two sides of the triangle proportionately. So if the line divides the two sides of the triangle proportionately, then it is parallel to the third side. So in triangle ABC, if AP by AB, I hope you can remember this, AP by AB is equal to AQ by AC is equal to AQ by AC, then PQ is parallel to BC. So these are the three lemmas you have to remember. So first one is, if two triangles are equiangular, then their corresponding sides are proportional, or if two triangles are equiangular, then they are similar. This is the first lemma. Second lemma is, if two triangles are congruent, no doubt they will be also similar. So two congruent triangles are always similar, right? And converse of DPT, if a line divides any two sides of a triangle proportionately, so don't fix to the proportionality like AP by PB is equal to AQ by QC only. So if a line divides any two sides of a triangle proportionately means the three possibilities, that is AP by PB is equal to AQ by QC, that is the first possibility. Second possibility is AP by AB is equal to AQ by AC, and third possibility is BP by AB is equal to QC by AC. That's also the third possibility. So if triangle ABC, out of the three possibilities, if any possibility happens here, 100% the line will be parallel to the third side, that is PQ parallel to BC. So this is the three lemmas where it is required to learn the Sas similarity of criterion, right? So now let us get into the theorem, very important. Right. So on board I have the statement of Sas similarity of criterion for similarity of triangles. So if one angle of one triangle is equal to one angle of the other triangle, so I have to take two triangles here. So out of those two triangles, one pair of corresponding angles are already equal. So one angle of the other triangle, and the sides including these angles are proportional. The sides including these angles, that is the corresponding angles are proportional, then we have to prove that the two triangles are similar. So to show that any two triangles are similar, now we have two options. One is AA criterion, another one is Sas criterion. So by using any of these two criterions, you can prove any two triangles to be similar. So AA criterion, so yesterday we have discussed that, that is if two triangles are equiangular, then we can prove that they are similar. So here in this criterion, that is Sas criterion, so we will go with the diagram and tell you how it goes. So I have to take two triangles here. So if one angle of one triangle is equal to one angle of the other triangle, so okay, I have to draw two triangles here. So this is one of the triangle, this is another triangle, right? So at last, as you have to prove that they are similar, both the triangles are similar, so therefore the shape of these two triangles should not be same. They should have the same shape but not the same size. Okay? So let us take it as triangle ABC. Let us take it as triangle PQR. Or okay, you can take it as DEF. Okay. So now, these are the two triangles. If one angle of one triangle, out of three angles, you have to select any one angle here. So let us select angle A, and when you for angle A in triangle ABC, angle D becomes the corresponding angle in triangle DAE. So this angle is equal to this. So one angle of one triangle is equal to one angle of the other triangle, and the sides including these angles. Okay. So this angle includes these two sides, and this angle includes these two sides. So now the sides including these angles are proportional. That is, the ratio between AB and DF is equal to AC is by DF. That is, the ratio between AB is to DE is equal to the ratio between AC is to DF. So for this angle, these two are the sides which are containing the angle, and for this angle, these two are the sides containing the angle. That is, these two sides contain the angle, these two sides contain the angle. So, in both the triangles, one pair of corresponding angles are equal and the sides containing these angles are proportional. So, if this happens in two triangles, no doubt the triangles can be proved that they are similar. So, but we will prove it logically first, then we will go with the numericals. Okay, let us write the description of the diagram, that is the data of the theorem. So, let us go with the data, write data here itself. Okay, so in triangle ABC and triangle DEF, in triangle ABC and triangle DEF, order is very important. If you take the name of the triangle ABC, you have to take it in this order, same order. If you take ACB, you have to take it as DFE. So you have to maintain that discipline. So in triangle ABC and triangle DEF, angle A is equal to angle D. Angle A is equal to angle D, and along with this, AB by DE is equal to AC by DF. AC by DF. So this is the given data for the given. So in both the triangles, the angle of one triangle is equal to one angle of the other triangle, and the sides containing these two angles are also proportional. So I have written the proportionality here. Then the two triangles are similar. So you have to prove that. What we have to prove? We have to prove that, right, triangle ABC is similar to triangle DEF. So you have to prove that triangle ABC is similar to triangle DEF. Very simple. So here, in order to prove this, the data what it has been given here is not sufficient. So therefore we will go with a little bit of construction. So we will go with the construction part. Construction part of the statement, we will get into this. So now, mark a point P on DE, Q on DF such that DP is equal to AB. This DP is equal to AB and AC is equal to DQ. And AC is equal to DQ, and join this PQ. Same construction we did it in the previous theorem, that is in the Sas Similarity Criterion proof. Okay, so mark a point that is P on DE, and Q on DF, such that, how we should mark, that's very important, such that AB is equal to DP, and AC is equal to DQ. AC is equal to DQ, and you have to join this PQ. So join PQ, right. So this is the construction part. Now, so they're using the construction part and the given data, we are going to prove that triangle ABC is similar to triangle DEF. Okay. Let us get into the proof. Right. Now, we will select these two triangles, that is triangle ABC and triangle DPQ. We will select these two triangles here. So, with the selection, we will move further, that is, just have to prove that this triangle and this triangle are congruent. Just I have taken this triangle inside this triangle and I have to prove that this is not different and this is not different. So, both are same. If I want to prove that two triangles are same, then I have to prove that they are congruent. So let us prove these two triangles as congruent. So in order to prove any two triangles congruent, we use postulates here. One is AAA, that is AA postulate, that is SAS postulate, ASA postulate, RHS postulate, that is some postulates related to triangles. So let's see, depending upon the data, available data, which postulate suits here. Okay. So in triangle ABC and triangle DPQ, in triangle ABC and triangle DPQ, so in both the triangles, angle BAC is equal to angle PDQ. Angle BAC is equal to angle PDQ. So because angle A is equal to angle B, it's already given. So angle A can be read as angle BAC and angle D can be read as angle PDQ. So here angle D is common for this triangle as well as this triangle. So angle EDF is nothing but angle PDQ. Vertex doesn't change. The length of the sides containing the angle is limited. It becomes less, that's all. But the vertex remains same. So therefore angle BAC is equal to angle PDQ. So this is according to the data. Right. And then, so clearly I have designed the triangles such that AB is equal to DP. We can see the same design which is done in construction. So AB is equal to DP according to the construction. Again AC is equal to DQ. AC is equal to DQ again according to the construction. So therefore, in both the triangles, one angle and two sides are correspondingly equal to one angle and the two sides. So therefore, triangle ABC is congruent to triangle DPQ. So according to that is SAS postulate. SAS postulate. So in yesterday's theorem, this was one of the lemma. So if two sides and an include angle of one triangle are correspondingly equal to the two sides and an include angle of the other triangle, then both the triangles are congruent to each other. That is according to SAS postulate. So now, so in lemma 2, just now what we did today, I just told you if two triangles are congruent, then they are to be similar. Two congruent triangles are always similar. So therefore, triangle ABC is similar to triangle DPQ. Now let us take it as equation 1 and stop it here. So triangle ABC, I have proved that it is similar to triangle DPQ. Now let us take this corresponding sides and continue with this. So now AB by DE is given. AB by DE is equal to AC by DF. AC by DF. AB by DE is equal to AC by DF. It is according to the data. Right now, here AB is equal to DP according to construction. So therefore, instead of AB, I can write the DP by DE is equal to AC is equal to DQ according to the construction. That is, this AC is equal to DQ. So instead of AC, I am going to write DQ. So DQ by DF. Because that is according to construction part. Okay. So now, if you apply this ratio, what we have got, dP by dE is equal to dQ by dF ratio, that proportionality in this triangle and see what happens. So let us look into that. dP by dE ratio is equal to dQ by dF. So in this triangle, what has happened is dP by dE is equal to dQ by dF. That means this line PQ is dividing these two sides of the triangle proportionately. Right? I hope you got the point now. So the line PQ, so I can write it in triangle DEF. In triangle DEF, dP by dE is equal to dQ by dF. So therefore, in triangle DF, this has happened. So once again I will show you. In triangle DEF, dP by dE is equal to dQ by dF. So that means the line PQ is dividing these two sides of the triangle, that is DE and DF, in the same ratio. So according to the converse of BPT, therefore according to converse of BPT, right, compulsory PQ should be parallel to EF. Therefore PQ should be parallel to EF, because if a line divides any two sides of a triangle proportionately, then it is parallel to the third side. So this is according to the converse of BPT, PQ parallel to EF. Now we will go back to the lemma, yesterday's lemma. When a line this is consider this PQ as a line, consider this EF as a line. So these two lines are now parallel to each other. So if you consider this as the transversal, then this angle will be equal to this because they are corresponding angles. And if you consider the same two lines are as parallel to each other, and if you consider now DF as the transversal, then this angle will be equal to this angle because they are corresponding angles. So when two parallel lines are intersected by transversals, then the corresponding angles are equal. So now, when you look at two triangles here, that is in triangle DPQ and triangle DEF, when you look at the two triangles, angle D is common for both the triangles, and angle DPQ is equal to angle DEF, that is in triangle DPQ, angle DPQ, and in triangle DEF, angle DEF are equal. So in a similar manner, in triangle DPQ, angle DQP, and in triangle DEF, angle DFE, that is this angle and this angle are equal. So in this triangle and in this triangle, corresponding angles, all the three pairs are equal. So then both the triangles are similar, that is triangle DPQ, therefore triangle, okay, now we'll write the angles. So angle DPQ is equal to angle DEF and angle DQP, this one. Angle DQP is equal to angle DFE. Angle DQP is equal to angle DFE. So therefore, triangle DPQ and triangle DEF are equiangular. They are equiangular. So according to the yesterday's theorem, what we did, that is, if two triangles are equiangular, then they should be compulsory similar. So therefore, triangle DPQ is similar to triangle DEF. So take it as equation 2. So this is according to AA criterion, which is done in yesterday's theorem. So triangle DPQ is similar to triangle DEF. So now compare equations 1 and 2. So here triangle ABC, that is triangle DPQ, is similar to triangle ABC, that is given here. Triangle DPQ is similar to triangle ABC, and now the same triangle DPQ is similar to triangle DEF. That means triangle DPQ is similar to triangle ABC, triangle DPQ is similar to triangle DEF. Then this is similar to this is similar to this. So therefore, this triangle and this triangle should be similar to each other. So that is triangle ABC is similar to DPQ, DPQ is similar to triangle DEF, that is from equations 1 and 2. So therefore, triangle ABC should be similar to triangle DEF. So from 1 and 2, equations 1 and 2, triangle ABC is similar to triangle DEF. Hence it is proof. So this is a beautiful proof for Sas Similarity Criterion, which is very important theorem. So most of the exams it has been asked for 4 marks. So please you have to practice this. Sas Similarity Criterion, Sas Similarity Criterion. Both the criterions on similarities are very important. So many problems, many identities and many riders are based on these theorems are going to come in the coming sessions. I hope you enjoyed the entire theorem. Please practice well, very important. Practice this. Without practice you won't get it. If somebody is proving the theorem, you can just enjoy it. But when you start applying logics, it feels a little bit difficult. But if you practice, you will be a master. Okay? So I hope you will practice this and take a good grip. So stay home, stay safe and keep learning. Thank you.